Welcome everybody to another Orbit online event. This time, once again, with our friends from Danske Bank. And this time we're happy to have two of our very earliest community members on the program, Anders and Alexander. So that's a good story of people coming to give back to the community. We like that. So before we begin, if I can change the slides. There you go. So before we begin, I'll tell you that this talk is being recorded. However, please hang tight, as of course, a live coding session always works better live. So here's what we have ahead of us this afternoon. A brief presentation of the team here today. As I mentioned, we have Alexander and Anders from Danske Bank, along with Frederikke and Josephine. You'll get to meet them in a minute. And my name is Lida, and I'm the community manager in Orbit Lab. So questions are welcome during the code along. There's also a Q&A session at the end, and I'll try to keep an eye on the chat as we move along with the talks. Also, actually, it would be nice if all of you would present yourselves in the chat, write who you are and where you're watching from. Here's a very quick advertising spot for another upcoming event we have on the 18th, where a team from MathWorks, the company behind MATLAB, is coming to tell us how to use MATLAB to accelerate development processes and engineering. And you can read more on our website, and I'll also put a link in the chat afterwards. And of course, we encourage you to keep following us on social media and to throw some likes in our direction. Alexander and Anders will share their slides, so I'll send them all out tomorrow along with the video recording. So now I'll leave you in the capable hands of Josephine and Frederikke. So over to you guys.
Thank you, Lida. So yeah, we just want to say welcome and thank you so much for signing up for this workshop in Microservices that we could do here in collaboration with Orbit Lab. So nice that it could be done. My name is Frederikke, and I work as a talent consultant in Danske Bank together with my colleague Josephine.
Yes.
Yeah, some of you might have seen us before at the university, even though it has been such a long time since. Some of you might be looking for an internship this fall, and that is actually why we just wanted to stop by to create some awareness that Danske Bank is looking for interns in the coming fall. And we actually do not want to go so much into detail about the program in itself, but show you a video that we have made that gives you like a glimpse of how it is to be an intern in Danske Bank. And then, of course, you're more than welcome to send an application to internship at danskebank.dk. Or else, I hope to see you on P-Day next Friday, where we also have the possibility to talk much more about the internship that Danske Bank offers. So yeah. I just want to show the video now and then say enjoy the rest of the afternoon with Anders and Alexander.
Sekant i Danske Bank, der ved jeg hver dag mange nye og spændende teknologier, og så har jeg en masse erfarne udviklere at spare med. Det, jeg synes er fedest ved min praktik, altså det er, at mine kodeopgaver rent faktisk giver værdi for Danske Banks kunder og mine kollegaer. Altså, man får opgaver på lige fod med de andre på teamet, og så kan det hurtigt ende med, at man har noget i produktion, som faktisk bliver benyttet af kunder.
Jeg har selv mulighed for at bestemme, hvor jeg gerne vil udvikle mig, både personligt og professionelt, og så praktikken samtidig også bare et godt springbræt for en længere karriere i Danske Bank. Man får et godt netværk blandt de andre praktikanter og studenter medhjælpere. Man kan virkelig mærke, at det er et gennemtænkt praktikforløb, hvor der både er fokus på det faglige, men i høj grad også det sociale, og det kan jeg jo kun anbefale til andre.
Great, but over to Anders and Alexander then.
Yes, I'll just share my slides or our slides. Can you see them? Can you see the slides?
At least I can see them.
Oh, that's nice. Then we'll just have a party, you and me, Anders. So welcome to our talk about microservices in a world of containers. This is me and Anders normally has a course for our interns in the bank where we do something similar for this, just a whole day. So we have tried to boil it a bit down. So first we'll talk about 40 minutes about microservices in a world of containers, where we first talk about microservices and then how to create them into containers, and afterwards how to actually run them in the world. So if we begin first, we just have this one. It was just to talk about Danske Bank, but Frederik has already done that, so that's
Propaganda.
Let's just proceed. So first, who are we? My name is Alexander. I'm an IT software engineering student in Danske Bank. I have been there for 2.5 years now, I think. Have been there since my internship in 18. And currently I'm studying computer engineering on the 3rd semester at Aarhus University. Yeah.
Then I can take over. So I think both me and Alexander has been spent a good bit of our time in Orbit Lab, and so as part of my internship, I was also up studying some engineering. I ended up going to Danske Bank. It sounded fun at that time, and then it kept on being fun because I actually managed to stay there for nearly 5 years now. A lot of the time I was there as a student worker, and then I was done the next day after I was done with my studying. Then I just started full time, because why not start full time? And I think why are we doing this talk? That might also be somewhat relevant, because can we actually teach you anything regarding Docker and Kubernetes? So I think at least both me and Alexander had experience both in our school, but also part of our working career out at Danske Bank, and also in our spare times. We had a tendency to go to all talks regarding this subject that we could here in Aarhus. So at least we have something to say regarding this. Then you can decide if it sounds good what we're saying. But at least we have a lot of stuff we want to teach you.
Yeah, but actually, I think first we would like to know kind of our audience, who we are talking to. So we have created a Menti, which would be nice if you guys would actually go to and then just answer the question, and then afterwards we have another question about if you know anything about this. This just to know who we are talking to and have an idea who our audience is. Yeah, so I'll just give you a couple of minutes or half a minute, and then we'll proceed.
If there happens to be anybody out there who doesn't know how to read a QR code, you can do it with the camera in your mobile phone.
Yeah, but you can just use the number by going to menti.com and then put in the number.
As well, yes. Perfect.
Yeah. Let's see. How many are we now? We are 22, and then I have to subtract a couple of people. I don't know if everybody has filled it out yet. Okay, I think we are kind of getting there then. Okay, and then let's see if I can figure out how this Menti work. If I can switch to the next slide. Yes. So now you should have another question. Do you know any of these kind of terms about microservices, Docker, and Kubernetes? If you know anything about them, it's just to figure out what people know, and hopefully we can teach you something.
Maybe you should put on a skill level, actually.
Okay.
Do you know it's a pretty wide...
Yeah, okay. But I don't know what else to...
No.
Okay, I think that's it. Let's just proceed then. Okay.
So by knowing, we hope we still can teach you something.
We hope we can teach you something else. You might ask deeper, and then we can hopefully answer the questions. It's hard to know where to put the skill level when you create a presentation, but that's why. So the first thing we'll talk about is microservices. So this is kind of a thing people have been starting to moving closer and closer to due to people wanting to move out of a complex coding system where everything runs within a monolith. So instead, people are trying to have this kind of structure where each of these kind of points here would have each own responsibility, and then they connect on the network. So first, what is a microservice in general? So normally when we talk about a microservice, we kind of want them to have single capabilities. That means that we model the microservices within a certain area of a business domain, which simply mean that this specific service should not do everything. It should only do a very small thing within the domain you are working in. They should be individual deployable. This means that if you want to, if you create a microservice, you should be able to deploy it without destroying any other things in the system. The system might have a degraded performance, but it should not take the whole system down. For example, if you have a monolith and then you deploy it and then you have something where it might be you might have an error, then it might go down totally because everything is dead. Then it should have its own data store. That means that there should not be any other services that has direct access to a data store. That means if you have a login service, that one has all the user data about the user and how to log in. And then if, for example, if you have something with, I don't know, accounts in a bank, then you have to contact a specific server and then contact this server that has the login credentials to get information about the users or know which one has access to a given account. Normally, we also say that microservices should be maintained by a small team. That means that you have a handful of microservices, and that team should be able to maintain that. They are replaceable / easy to refactor because they are small. It's not like you get 10,000 lines of code and you have no idea where to begin. They should be easy to grasp and easy to refactor if needed. And they are kind of independent, so that means that as the individual deployable, that they of course have dependencies to other services, but they should be able to run something on its own. So the way we normally talks about microservices when they communicate, it's either via a REST API or remote procedure protocols or a message queue. That's different ways of communication. That's normally over the network, and that's normally what we think about when we are talking microservices in general. Then these terms, loose coupling and high cohesion, is general software terms that microservices also should have. So that means that we have to, in the microservice, it's nice to have a great interface. So when you change the microservice, the interface would be the same, but you can change everything within the microservice. And then it will still, for all the other services, will still be able to interact with this specific service without any problems. Yeah, and the microservice has to make sense what you put into the microservice. So you should not have anything that, for example, has being able to calculate something while it's also responsible for doing the visual thing. If we move along, this is just a short picture of how microservices interact. So let's say that if we have this microservice A that needs to gather some data, it can contact B and then get the data store. That actually means, like I said before, it should not access others' data store, it should only access its own. So for example, this would not be allowed in a microservice architecture, but for example, if we have this normal architecture where we have everything in a monolith, it's way easier to just do something that are really that just digs in and takes other data that are not the data that specific part of the code owns. This is especially a problem, we can say, for the mainframe, where a different part of the mainframe actually just access directly tables, which means that sometimes you don't own the data you're trying to get, so nobody actually knows that you are doing this, and that makes it really hard to figure out how to, for example, refactor the table or create a new table or something like that.
I think if take an example from our everyday life is that I think at Danske Bank we have a tendency to don't ever delete any columns in our tables, because we are really scared that someone else that we don't know about is using the tables on the mainframe. So that's been an issue for us, at least.
You only add stuff.
And then 5 years later or 20 years later, then you have a very large table with a lot of columns because you only add to it, you never remove.
Yeah. And then a golden rule from Sam Newman, if anybody knows him, you can make a change to a service and deploy it by itself without changing anything. That's kind of what we want to achieve here. So we want to have interfaces that you interact with that are kind of stable or stable most of the time, and then you can just change however you do stuff inside your microservice. So short about the pros and cons about microservices. The pros about microservices that is really modular, so you can just create a new service and remove a service if you don't use it. You can use kind of the tools that you need for the specific service. That means that if you have within some specific domain where it makes really good sense to use a specific language or something, a framework, you can use that in only that regard, and then use a other tool like C# for doing another microservice. That means that you can create microservices within different languages, whatever you prefer, but you still have to be aware that for the specific team, you need to not do it too complex. So be aware that you should not have 20 different languages in 20 different microservices. Kind of keep it stable for the teams to be able to maintain it when you, for example, leave the team. Microservices also provide a great scalability, because one of the main things general about microservices is that they are stateless, in the regard that you can just scale up. And for example, if you needed to have 10 microservices running side by side instead of only having one, that means let's say we have a high load on Black Friday, that we will be able to scale to that specific load the given day, because we can just, if we use a normal cloud provider, we'll just be able to create more instances of our microservice. Due to the way that it's small, it should be really understandable pretty easy, because you don't have 100,000 lines of code that you need to understand to really figure out how the system works, and then you use some different stuff here and there from other modules in the system. Here the microservice is small, it's understandable, and then you have for example, a REST, an HTTP client that uses a REST endpoint in one of the other microservices to connect to. So it kind of makes the microservice understandable by itself. It's ready for the cloud, as I talked about before. It's easy to scale, so when you want to go to the cloud, you're ready, easily at least. And for something like continuous integration, continuous delivery, it's pretty easy to, for example, if you like what we will talk about later, Kubernetes, it will be pretty easy to just create a new microservices and then deploy it. Some of the problems with microservices is, for example, we rely a lot on the network, and the network has a lot of latency compared to, for example, the mainframe that we normally also work with in Danske Bank. So that means that something will be at least be slower than it is today, and it also moves a lot of complexity to the network and how the whole network should be structured with different layers of IP and that kind of setup. one of the other things that you lose when you go to a microservice architecture is traceability. It's really hard sometimes. There is software that can help you with this, but in general, it's hard to do. Because, for example, when you debug stuff, you cannot just hook into your code and then run it, because at some point you're just calling another endpoint and you don't know where then where it goes wrong in the network, for example. And when you create microservices, you model it, as I told before, about a specific business domain. That's kind of hard to get right. And so because you don't want to create the microservice too big, but creating it too small will also create an overhead. So it's hard to kind of figure out how big should the microservice be. So a thumb rule could be that you would rather create it a little bit too big in the beginning, and then afterwards maybe scale it down if you figure out that you need to divide it into smaller pieces. So I think now Anders will talk a bit about Docker.
Yes, I can do that. So when we're talking about containers, then a lot of people or developers think about Docker. So Docker is this tool that you can say, containers, yay, now we actually have a container. So is that a container ship? Nope, that's not it. But it is. There's a reason why they actually decided to go with that idea, because it is to some degree pretty similar, because we can put a lot of stuff into this container, a lot of different stuff. So in this case, a lot of containers. It could be a lot of different classes and everything. So why are we talking about these containers? I think just to get a bit of history. So Google, it's a pretty big company, and they would actually like to run a lot of different software. They also decided to build a cloud and everything. So they wanted to run something that was not interfering too much with each other. So of course, everyone was running VMs 10 years ago or so. Google figured out that was not optimal, because each VM takes a lot of resources. At least they did at that time. So they actually wanted to change it up a bit to see if they could figure out a way that they could create something similar. So you get the isolation, the abstraction away, but maybe you don't need to have 2 gigabytes of RAM for each different service. So they tried to create something that what they call the containers here. And they had, before, what we're going to talk about on later is this Docker and Kubernetes and everything. They had some other systems to do this. They called it Borg and another one, I forgot the name. Omega. That Omega was killed pretty fast, but they're still running Borg in production. So then later on, we're going to talk a bit about this Kubernetes, but that's what later on became Kubernetes, or they tried to evolve it to actually something that everyone else could use. So why are we doing this? I think Alexander, he talked about scaling. So what we really want is we want to be able to scale, and Docker is giving us some of those things. There's some things in regards to that we can actually have multiple of these containers, and they will part of their nature is to reduce the overhead by being able to take some of the usage from the VM underneath that Alexander is going to talk about a bit later. So we actually get a lot of really nice scaling, so we can scale up a lot of containers, and then we don't have a lot of overhead of using a lot of RAM. That's not really giving that much. But there's also a bit of issues here, because we're not gonna get the same isolation that we had previously in VMs. So
I'll just mute him.
can you? Yeah.
Yes, done.
So we do not get the isolation, but for now that's fine for most companies. I think there's some companies that's working on trying to do something with VMs they call micro VMs, but for most companies it's actually fine to just have containers to separate the different, you can see, services. So we have this about custom fit to your needs. So one really cool thing about containers is that you can actually do a lot of different stuff. So you might have an application, and it's very important that that application runs with Python version 3.7 or something like that. And then you have another container that needs to run with Python version 3.8, because there's some specific features, and if you run with the wrong version, everything doesn't work. So in the case of containers, that's actually really easy to set up, and we will take a look at that later. So you can actually really customize them and set everything up. And then the good thing about this, you get this consistency. So when I've created something, and now I'm saying it is consistency, we hopefully should not get that much of it works on my machine. I think you have a tendency to say, a lot of people say you would never get it anymore, but I think that, at least in my case, has proven wrong. I have had Docker containers working on my machine and not on other people's machines, but at least it should be limited. That's the whole point, that we don't need to do some kind of all having this exact version of .NET or having the exact version of Java on my machine. I just need to have Docker, and then all of the other stuff that would actually be part of this image that we're going to create, that we can spin up our container. So we're going to get it out of the box, or at least somewhat. So if we, in this case with Docker, there exist other tools, but I think Docker is the large one in this case. They're the big player. They still have an issue trying to figure out how to make money off it, being the biggest player on the playing field. But yeah, so you actually get some pretty nice out of the box tools with Docker. You can do a lot of interesting stuff trying to set up, spin up fast stuff. That's also the good thing about these containers, is also you really fast could. So Alexander has created some really nice stuff to lock. Then I can just fast, if he had created this container generically, I can just grab his container and use it in my system. So it's like modules. You can just build up all of your system together of containers you create, but also containers other people do. And that's really useful, especially in regards to locking and monitoring and all that stuff that comes along with having an enterprise solution. So all of those containers is pretty fast to spin up, and we might tackle on some of that stuff later on. I think, will you continue?
Yeah, also one of the things with the out-of-the-box solution is we all know when we install Microsoft Visual Studio that we need a SQL container for doing, or an SQL server for doing some stuff. And then you have to install that as well. For example, here you could just download a specific container with Microsoft SQL installed in it, and then you actually have an SQL server on your computer that you can just spin up when you need it and shut down when you're done. So that makes fast installation of a lot of, for example, different types of databases that you don't have to install on your computer. You can just have a container for it.
And the good thing is, it will work on your Windows machine. It will also work on your Mac, and it will work on your Linux machine, and probably also on most Linux distributions.
Yes. So here we have the container versus virtual machine that Anders shortly talked about before. So if we look here to the right, we have the virtual machines. That was how it was kind of done back in the day, where you have an app A, B, and C, and you actually needed to have a virtual machine for each of the apps to provide isolation, as well as when, for example, like Anders talked about, he needed Python 3.7 for something and Python 3.8 for something else, then you would have a problem here on these machines, or you will have to do some not default stuff at least to make it work, and then you'll still not have the separation. So what this is, that you both have a separation on these the virtual machines for the apps, as well as the dependencies you need would be on each of the machines. And you have this overhead of having to run a operating system 3 times. So that means that at least some of the CPU and RAM would be used as an overhead for each of the virtual machines. Where here to the left, we have a containerized application. That means we have only one operating system, that's the host operating system. And on top of that, we run the Docker application. And then we can run 6 apps here in parallel, and these will be isolated in a specific way that Docker provides isolation due to specific how Linux is configured with some different namespaces in regards to network and CPU and other stuff that here then you can't do any cross-process communication to provide that specific isolation. So that means that we can run more apps on each hardware server due to not having to run so many operating systems on the side.
So let's take a look. So with Docker comes a command line interface. And just to have a short introduction to some of the ones that we're going to take a look at later on, then we have the Docker PS that's showing all the running containers you have on your system. Then we have Docker images, because as part of this, you can have containers and you can have images. So images is like the recipe for what is going to be in this container whenever you spin it up. So we create an image, and that's just like a bundle of whatever is gonna. It tells you what is the current in here is the base system, for instance, a Linux based system. Have you added some code to run an API or application? And then it also tells whenever people want to start up this container by default, what should it run? Should it actually run the API? Should it run the service? So that's the images. And then we can actually containers. Then we can run this image multiple times, and then we have multiple containers. But we'll take a look at that later on. Then we have the Docker build. That's also pretty interesting, because that's the one we're going to do when we're actually going to build our images. So we have some source code. We have like this recipe that is a Docker file that defines.
That you show on the next slide, I think.
Exactly. And then we have a Docker run. That's actually for running our containers. So a container is no fun if it's not running. So we want to run the containers so we can actually access, for instance, our application, see maybe a web page or an API. Then we have an exec commando. That's just if you want to, for instance, go into your Linux system here. In our case, if it's a Linux container, we can actually go into this container and try to run some commands against it, see if anything is not working. We could try to take a look into it, see how have we actually managed to get all our necessary files into it. Is something wrong? Then we can clean up a bit up after ourselves, remove some containers, remove some images. Then we have the Docker tag commando. So Docker tag is part of this Docker environment is that you normally want to take these containers, build them maybe on a CI/CD pipeline or on your local computer, and then you want to push it somewhere. You don't want to have it on your computer because you want other people to use it, or you can say systems to actually grab these containers and then host them. So you want to push them somewhere. And part of this Docker tag, that is like the name you give the Docker containers. And part of the idea of Docker is you're very explicit and say, so you actually write out what is the server that's hosting it. And if you do not write out like the URL for it, then it's just going to default to this Docker hub, which is like the default one. But if you do write it out, then then you do this Docker push commando as the last thing, then it's actually going to push up the image to Docker hub, or in our case in Danske Bank, then you have our own internal software, you can say, called Artifactory, for actually hosting a lot of these stuff. So we would write something like artifactory.danskebank.com or something like that, and then whatever our name of our image is, and then we do Docker push, then it automatically push it up to our Artifactory. Let's move on. So now we have this Docker file. So this Docker file is like the recipe for actually doing whatever we want to do. So in this case, we have taken out the .NET 5.0. So that's going to be our base image. So in this case, we have created this from command. So this from command, that's defining. So we want to build our application on top of another Docker image. So we're actually saying we would like to use this Docker image and then build something on top of that. So this is a Docker image created by Microsoft. So we would like to use that as a base for building on top of. So what we're showing here is just a totally default one generated by Visual Studio. So this is a bit more complex than some of the other Docker files that exist. This is a multi-stage, that meaning that they can create a very small image, but they do all of the building and everything inside the image. So we have a base image in the top, work here, that's like setting the current directory. Then we have some expose, that's not important. That's like telling people what are the normal ports that will be used in this application. Then we have the next thing, that's going to be like our build. You can see here, this is a different image it's using. Instead of the ASP.NET, it's using now the SDK. Because when we're building, we would actually like to have all the build tools there. So in the end, we don't want to have all the build tools on our image because we want small images. We want to optimize it as much as possible. So we don't want a 200 megabyte image if we can do it with 50 megabytes. So we want the small image for actually to use in the end when we have built everything. So here, yeah, we're using the SDK, setting the work to the source. Then we're copying in our CS.point file. So all of this is just automatically. So in .NET, you have this CS.point file. This is similar to the XML files in Java, anything that defines what NuGet packages or Maven packages we're actually using. And then we actually do a restore on that. So the question is, why do we not just copy in all of the code, but why do we copy in first these CSPOI files? So the reason why we are doing that, that's because in Docker there's something called layers. And those layers, they're pretty smart. So instead of just running this every time from the start, Docker knows if nothing has changed, why should I then rerun the commands? So what it does, if we do it like this, and I never really do a change in the CSPOI file, if I don't add any new packages that this tool is using, then Docker just know if I have been running this command before, then there's no need to run it again. So what it does is it's just going to say, oh, I already did this. This has the correct share value, so I'm just going to reuse this one. So it has all of these layers from previously. So it's just automatically going to go over and say, yeah, everything is already restored. So now I just need to copy in this all of the code you actually done, but all the packages are already restored.
Yeah, and the reason you want to do it specifically for restore is that can take a lot of time sometimes. So that's pretty nice to actually have that specific thing cached before doing anything else.
Exactly. And then if you just move on a bit, then we do a work tier for setting a new where we want to go to, and then we actually do the .NET build. So that's just in .NET, that's the build command for actually building this project. And then the next line, then we do a from, where we actually take that's just .NET's way of doing it, but we're taking the build we had previously, and then you're just going to do a single command inside this new one that's called publish. So here we did the build before, and now we're actually just publishing whatever we need to this folder. And then as the last thing, here we are basing on the base image. So that's the small image. That's the 50 megabyte image that we wanna base everything on. And then we're gonna take whatever we build up there. That means in .NET, that's the DLLs. In Java, it could be the jar file, and just only put that in there. So we want a very small image with only necessary things for running our application. And then in the very end, we define an entry point. So the entry point is whenever Alexander wanna start up this image here, that should as the default, that should be what's starting. So in this case, we want to start the microservice.dll. Let's move on.
Yeah, so now we have an idea of what containers are. And as we saw before, there was this Docker run command, but that is smart if you just want to test stuff locally. But what if you want to be able to scale it? Docker doesn't really come with anything anymore about how to scale. It had something back in the days, but it was kind of out of date today because Kubernetes kind of beat it to the market. So today we could call Kubernetes the de facto standard of how to doing container orchestration. So first, a bit about Kubernetes. As Anna said before, this is created by Google, and I can't remember when. It's 6 years ago or something. But they first had this thing called Borg and then Omega, which were internal projects of container orchestration that they used internally to run all their stuff. We know that Google has a lot, so they need something clever to do it. Then later, Kubernetes has been gifted to the Linux Foundation, where it's actually kind of the center of a sub foundation called CNCF, or Cloud Native Computer Foundation, which is a foundation that has a lot of cloud native stuff. And when I say that Kubernetes is kind of the center of the CNCF, that means that all the other stuff all the other projects that are in this kind of relies a bit upon Kubernetes. At least they interact really well with Kubernetes. Like you can get some monitoring out of the box that just works, that you can to monitor your different containers and your cluster and other stuff. And all big cloud providers like Google, Azure, Amazon, they have Kubernetes as a service. So you can just say you want a Kubernetes service, and then of course, you have to pay for it, but then you have it out of the box, and it works, and it's using at least one of the newest versions. I don't think they are at the newest version all the time, but I think they are within the supported window of updates. But what Kubernetes really does well, other than it does scaling really well, horizontal scaling well, where we have all these containers and we can scale them out, so we can use Kubernetes to horizontal scale all our our pods. It is called in container what we would normally call pods. I'll tell a bit about that later. And then it gives us something we call self-healing, which means that if our application crashes, Kubernetes will notice that this thing is crashed, and then it will actually restart it, which is pretty nice because sometimes we don't know why our code crashes, but it does. So this Kubernetes will secure that it actually just heals up and starts running again. So first, a bit about the architecture of Kubernetes. This seems like a lot, but I'll try to explain at least a bit of it, and then all the red boxes here is something you don't have to think about. But we are here as developers, and we have two ways we can interact with our Kubernetes cluster. We can either use a graphical interface. I think Anders will show how to install this because it's not default. And then we will also have a command line interface, which is probably normally what we do and what we use to interact with the cluster. Yeah, and these two things talk with what is called an API server on Kubernetes. And Kubernetes has kind of what we call nodes, two types of nodes. They have a control plane, which is kind of the brain of the Kubernetes cluster. This is normally you would have 3 of these at least to have some kind of quorum/consensus, which means that if one of them goes down, there's still a form of majority in the cluster that decides how the current state is. And then we have the worker nodes, which is where we will place all our applications. Yeah, and then like Anders talked about before, up here we have a container registry. Sometimes it's Docker Hub, sometimes it's from Microsoft or from Google, where you as a developer create your app, you push it up here, and then the Kubernetes cluster knows how to pull from this container registry when you give it specific commands through the either the command line tool or the graphical user interface. So first, a bit about the basics. The basic unit in Kubernetes when we talk about running apps is a pod. A pod normally contains a container or more than one container. Normally, and for today, we'll only think about that a pod contains one container. You can do it with more, but generally there's not a lot of good use cases. There are good use cases for running more than one, but generally that's not something we'll do as normal application developers, having more than 2 containers. This is when you do specific things where you have some containers that needs to interact really closely, but doesn't run as the same process. But that's not something we'll go deeper into today. So we have this basic unit, and what do we do with that? We want to run them, and we want to run many of them. Therefore, there's this thing called a replication set. This is a way to run multiple pods that are exactly the same. This means that we can here set a given number, and then we run this amount of replication sets. Then let's say I want to change this replicas to only have 2 because now it's died and there's nobody using my system. Then I change this to 2 and the replication set will automatically scale it down, close one of the pods down, and we'll only have 2 pods running. And you could do the other way around, so you could set this to 3 and then it would just create a new one. So that sounds smart, but then let's create another layer of abstraction. We have an abstraction called a deployment. What a deployment is kind of a way to create replica sets. Okay, this seems a bit weird, but why would we do that? The reason we want to create a deployment is actually to be able to create rolling updates and rolling rollbacks. That means that when we update, instead of having downtime, we can actually create another replication set. Currently, it has 0 replicas, but this deployment knows that we want the version 2 of our replica set, which uses a new container. So it will close down one over here and then move it over here. And gradually we will move all our stuff to run with the newest version. And all our customers wouldn't notice anything because everything was up and we didn't have any downtime when we deployed. that's the reason why we have a deployment. Else you would have to do this manually, which it's not nice to do the roll out by yourself. It's messy, but you can do it if you want to. So here we have a deployment YAML. I think Anders will shortly go through a bit of it, but I think you will also talk about it later.
Yeah, we'll take a look at it later when we're gonna actually code some stuff. But yeah, shortly, I think if you're not familiar with YAML, YAML can be a pain in the ass because if you indent wrong, then stuff doesn't work. But yeah, pretty much you have a. If we're just gonna go through it fast, the important lines are line 2, where you have the deployment. So that's actually the kind. So there's a lot of different kinds. I don't know how many we actually have in default Kubernetes, but around 30 or so. And I think there's like 3 or 4 that is the most used, that includes deployment as the primary one that a lot of people use, and that's the one that's probably going to be most familiar. Then we have some metadata that includes some name and some labels for the deployment. And Alexander talked a bit about these pods, because what's interesting in the deployment is you actually define the definition for the pods down in this spec one. So here we define actually what is going to be the amount of replicas. In this case, we have 3. Then we're going to define a selector. So the selector is pretty interesting because these selectors in Kubernetes are pretty important, because if you do not do the selection right, then it's not going to be able to connect your different objects. So for instance, we're going to talk about a service later on. If you do not connect these things correctly, then it doesn't know that they should be connected. Makes sense. So if we go down there, then a bit of interesting stuff. If you go down to the containers part, there's this thing called image. So the image is pretty important because that's actually the stuff we have built in Docker. That's actually our image from Docker. So we have given it a name. In our case, it's called microservice. And then you have a colon, and then we have a tag. So in our case, a tag would normally be a version. There's also normally one that's called latest. That could be like the latest version. But else, as a default, then you would have some kind. In this case, it's version 1. And then we define what ports this is actually going to be exposing. I think that was a short walkthrough.
Yes, and like Anna said, we have these label selectors that are pretty important. I haven't really talked about it yet because there is it's used in different places. Also, the replica set uses these labels, but here it's really important that you match the labels when you create a service. But what is a service? Sometimes we want to be able to actually access our pods. If we create an API, it's pretty nice that Anders actually has the chance to go in and call the API from his own local machine or from the World Wide Web or whatever he wants to do. So therefore, we need to use this term called a service. That is kind of like an load balancer, if you know what that is, where you can connect to the service and then it just forwards you to one of these pods. And the way the service knows which pods it should match with is actually this label selector. So it has this app called Microservice, and then down here the pods have a certain label called app Microservice, and that way they actually match together. And if this is not done correctly, the service will just point to nowhere. So when you would access it, you wouldn't get anything other than an error. So that's pretty important to match. And if we go to the YAML file here, you can see here we have the specific app selector that we need to have on the service that it selects. But else, I think Anders walked kind of through the YAML before. It's not the same type because this has the kind called service here instead of deployment, and then we have a specific selector here that selects the pods we need. And down here we tells which kind of port we use, and there's 3 types of services in Kubernetes. One called load balancer. This one means that we expose stuff to the outside world. Then we have something called a cluster IP. That means we have something inside the cluster that is not exposed to us as developers. And then we have a last thing called node port that, as far as we know, is not used a lot, but actually the load balancer is based upon the node port. So it's used in the implementation of this one. And then up here in the ports, we have the port that we use internally, that are port 80, and we have the port that we need to access from the outside, which is port 8080. Yes. So now, shortly, this is just links to the documentation. Actually, even though Kubernetes is open source, it has a lot of really great documentation normally, so it's easy to find what we want. So we just put it in here for deployment and service, which is what we are going to use today. And there's also some, let's call it advanced topics, at least for today, where there's a lot more than just this, but this is some of the most used other than the one we talked about. And there's the link for the documentation. And then I think maybe we should have 5 minutes, and then Anders will take it away with some code along stuff.
Actually, there are some questions in the chat. I discovered it a bit late because they didn't update in time in the app that I have open. But
Okay.
let's have a look. So there's one from Ulrik. I've expected diverging behavior for containers when the hosts ran different versions of the Linux kernel. Well, that's more of a comment, really.
Yeah,
Only for
there is something where if you run specific kernels, you might have problems. But normally, when, for example, you run in a cloud environment or stuff like that, you would run on similar kernel versions, not specifically the same, but normally it's not a big problem. It's only if you are going, for example, up in major numbers in the kernel, Linux kernel numbers, that you might have a problem. But yes, it's true, there could be something there. But yeah, as you say, it's a niche case.
Perfect.
That's probably also why some are trying to use VMs instead, these micro VMs where you can actually give it a kernel together with it, so you do not have these issues, and you can continually.
Right. Yes. So we have a question from Abdul. But if containers reboot periodically, wouldn't you lose data in the database?
When you have a database, for example, you would normally do something, I linked to the documentation here, called volumes. So you normally do something where you mount in a volume for a specific container and do stuff there. We didn't want to talk about that today because I think that would be too advanced and too much stuff to put in. But if you have databases, you need to do something with volumes where you mount it in, so you'll keep the state even if it restarts. That's true.
And we actually have an example of that in the task, you can say. We're probably not going to manage to get that long today, but if you take a look at the GitHub repo, then there's the last task that actually showcases this.
But I can actually see that Morten answered the question.
Yeah.
So thank you.
That's helpful.
Yes, and you can probably also use VS Code. But let's try to get going and see if we can actually get somewhere. So if we just take I created this nice GitHub here. So if you're stuck at any point, then I actually try to create some checkpoints that you can actually. So either if you're going through it now, or if you at some point later on would try to try it out yourself and you don't know what to do, you can just do like a git checkout. Git checkout, and then whatever tag you have here, and you just automatically get the code that is, should be there at that point of time. But let's try to see what the first task is. So to try to understand this, then it could be pretty nice. We could just create a very simple API that outputs the current machine name. Why is that nice? Because when we start spinning stuff up in Docker containers, then they will have their own machine name. So it would be pretty nice if we could actually take a look at that one. So let's try to see if that can work out. So we're going to create a new project. And now I'm doing this through this slow UI, but using this ASP.NET Core application. And let's call it a API. And let's not put it there. So let's create own. And what we want to do is actually create just a very simple API. So we're just going to use their ASP.NET Core Web API. I have the newest version of .NET Core, which is the version 5. It gives me some nice settings I can set from out here. I can, for instance, enable Docker support. I can also do that in previous versions. And what is new in this 5 is I can actually enable OpenAPI support. If you have not created APIs before, then being able to enable this, getting Swagger and everything just by the click of a button is pretty nice. It was also rather simple previously, but now you can just get it by setting up this default project. So let's try to create that one. So, and this is the thing you don't like about Visual Studio.
10 years later. Yeah, that's how it is.
So, yes. Send all my information.
Sell your life to Google
Yes.
or JetBrains in this case.
Oh, this was the Russian guys, or wherever they're from.
Oh yeah, that's true. I think they're from Czech. I don't know.
Yes, but so right now, so by enabling Docker support, we actually get the possibilities inside Visual Studio to actually debug, etc. in Docker, which is pretty nice because some of the things here in life might get messy when you go into Docker. Because if you have been on a Windows machine, then for instance, when you do references to path and everything, then you do a backslash. If you're on a Linux base system, then you do a /. So if you're not able to like debug it, then sometimes you can run into some issues. So they have it enabled so you can actually debug it up here in Docker. It sometimes might come with some issues since it needs some access to your local drive, etc. But sometimes it's just in Visual Studio to run it twice and then it works. So let's say, so I don't know how many of you knows about APIs. Is that a common thing or is that an unknown thing? Just to know what level.
I would guess based on that people knew Docker and Kubernetes, and a lot of them were 5th semester, they should know, or 5th or above, they should know.
So we're just gonna say that this is a somewhat known knowledge in this.
If not, please speak up.
Yeah, then please tell us. API is love. API is life. Yeah, indeed. So I hope you can see. I actually didn't change my coloring, but I've zoomed in a good bit. So we have a very default controller here. If you're just gonna now, I'm just gonna start it up on my local machine as Kestrel, just to see how it looks. And it's just gonna start up in a few seconds, hopefully. So what we just wanna do here is we're gonna add a new controller here. And it's gonna publish our machine name, but let's take a look at no, thank you. Come on, you can do this.
While you're waiting, we can discuss why you're using Edge.
It's because I'm a opposite of Abdul. I am a giant fan of Microsoft, and I love their new Chromium browser. So I'm a fanboy. I like where it's going. They're gonna become the market leader of everything in life. And why is this gonna? Yeah, now it's coming. Good.
Okay,
Yeah, it looks like it, Anders.
Yes.
Market leader 2 years later.
3 years later. You don't need to be fast. You just need to work all the time. So here we have this basic API. Let's try to add a new controller. We call the machine name or environment. Let's go.
I can see we have a lot of Firefox fans. Maybe you should try that one on us.
Firefox.
Yeah.
What? Just because they don't sell all my stuff? Why would that make me happy?
Doesn't they eat more RAM than Chrome, even though that shouldn't be possible?
So now I'm just creating a new method here, returning a string. Well, we wanted to return the machine name. So let's just see if I run this on my local machine. How does that actually work out? Hopefully it should say some random string that is actually my machine name.
Hopefully it's faster than last time you started it.
Yeah, it should be.
Are you sure?
No, I'm not sure. While it's spending some time starting, then we can just take a look at this Docker file. So this should be very, very similar to the one that Alexander showed. I think the only difference should really be that I'm only exposing port 80 since I disabled the HTTPS part. So I don't want to really play around with HTTPS for now. And then we have all of this stuff. So the next step is when this is going to start up, then we should actually be able to see the machine name, and then we want to start it up and take a look at how it actually looks when I try it out in Docker manually. Hey, this is my machine. Top secret. So let's try to start it up in Docker instead. So we could start it up in Docker in here, but let's try out the CI tool, command line tool. So let's go into this demo. Oh, I call it demo.
You called it API, I think.
I called it API. Good. So yeah, right here. So if we do ls on the API folder, screw me. Then we can actually see the Docker file in here. So the default way that it's going to build when you use like the build-in in Visual Studio is that you actually need to have your context standing out in the folder beside your solution file. So if we take a look at this folder here, we are just beside the solution file. So we can do like Docker build. That's the command we're using for building. Then we do like a tag. So in our case, this is very important. We call it API. And then we set the context. So this is the first time you're using Docker build. If you're not aware of the command you find on the internet, there's a dot, and you think that's probably not meant to be part of this command. But it's very important because without this one, it's going to fail. So if you do like this, it doesn't understand anything. So we want the dot. Oh, and then I want to actually be clever. So in this case here, there's in this folder we had right here, there's no Docker file. So by default, it's looking in the folder I am to see if there's a Docker file. There's not. So let's define that there should be a Docker file. But that one is inside this folder here. And now I'm trying to build. So as you can see here, the restore, that's the one that's actually taking a good bit of time here. So these layers we talked about previously, it could be pretty nice if they could actually just have that on my machine already. So let's just try to see what happens if I try to build it again right now. So if I try to build it again right now, then it instantly done. But if I then do a small change, it might just do a change here. So it might take a little bit longer. But should still be pretty fast because it doesn't need to do the restore. It only needs to do the build of the application. So at least we save a bit of time comparing to trying to restore all of these. So now we've created this solution. And that's what we called it. So let's just take a look here. So we can do Docker images. Take a look at all our images. And I have a lot of images. I have some. So we have this API here. That's built 11 seconds ago. So let's try to run it. Just clear this. Run. Then if I run with -it, I can do it like interactive. And then I can do API and then the version. Then it's pretty important that if I just do like this, then the container will spin up and run, but I would not be able to access it on my local machine. So let's just expose a port and let's hope nothing else is running. We can just do like Docker ps to see if anything is running. Yeah, but that's the one from Visual Studio, I think, so that's fine. Let's try to expose it on port 80. At least it says it's listening on port 80 here, so that should be fine. Let's see if it actually works. Docker. Oh,
no, localhost.
Yeah. And then we had port 80, that's fine, that's the default one. And then we have the
Swagger.
Yeah, but Swagger would not work because by default it's only exposing when it's on development environment. So instead I can do this weather forecast. So that's working. So now we're actually hitting the container in our local Docker. So if I can remember how I did it, that's probably the environment here. So as you can see now we actually have this weird number instead of the one we had previously. So why do we have exactly this number? So if you take a look in here, I'm just going to start up a new one here, Docker ps. Then if we take a look at this one, it should hopefully be the same, and it's the same. So it is actually container name here. So what happens then if we decide to spin up a new one? So we could actually spin up another one, and we want to expose it on port 81 instead. And yes, so let's try to hit that one instead. And as you can see, this is the other ID. So.
But Anders, I want
Yes.
10. Can you please give me 10?
Yes. So when Alexander now say he wants 10, and in 2 days he wants 100, then it becomes a bit cumbersome, and you also need to expose a lot of ports and everything. Maybe this could be done smarter. So let's take a look at this this Kubernetes stuff. So Kubernetes is normally a distributed system that you have a lot of servers. I think it's to some degree to abstract away all of this VMs that you need to, for instance, have if you have multiple data centers and everything, you want to host it and ensure that you get high availability, and you don't want to, you just want your service to always run, right? You actually don't care if there's 5 instances or there's 500. You just want, whenever Alexander goes to this web page, he just wants it to be fast. He don't care if there's actually 5 underneath that's running. And he don't care if East European data center goes down. So to some degree, Kubernetes is just yet to abstract that away. So it's just simple.
But also, as a developer, you don't want to go into a Linux machine and doing some stuff and setting up stuff and figure out how to do stuff. You want to have code and then put it nicely into the cloud without doing a lot of configuration, because a lot of developers don't think that's fun to do.
Yes.
Therefore, Kubernetes can kind of abstract it away.
And now we might lose Abdul a bit if he had not. Abdul, sorry. Yes, so if it is not enabled, so as part of this Docker, so if you have installed Docker, then we can run the Docker commands. But as part of Docker, you can also enable Kubernetes in here. So that's actually pretty nice that you can actually. I'm not sure if it's joking or not. But yeah, so you can enable the Kubernetes here. So what you want to do is actually enable Kubernetes. So we enable Kubernetes here, and then we actually have a Kubernetes system. So compared to how it was 2 or 3 years ago, this is really easy to get a Kubernetes up and running. That's perfect. Then I can actually just go along. Then so yeah, we get a Kubernetes up and running, and that means, so like Docker, we actually have some commands here, and then let's hope I actually have the correct one. Yes. So in this case, Kubernetes get nodes. Since we talked about it being a distributed system, then normally you would have a lot of nodes. In our very large system here on my computer, we have a single node. But normally in distributed systems, I think Kubernetes supports more than 5,000 nodes, and a node would normally be a VM or a physical machine. So I think some of these systems are really, really huge. But for now, it's actually pretty nice that I don't need to have a really, really huge system to test something out, maybe spin up a few services and see how they interact together. So let's try to see how this actually works out. That we so what do we do now? We have created our Docker image, but Alexander talked a bit about these YAML files that we actually need to use. So let's try to see if we can actually create the YAML file. So let's just see, what did the guide say? So the guide actually tells me to install a Kubernetes dashboard. So let's just do that. That takes a few seconds. So Kubernetes dashboard is that we actually want to be able to see these instead of. So if you're not that you can say good at your command line tool, or don't want to spend too much time in the terminal, then maybe a UI is nice. We can do all of the stuff that we want here. Get pods, then we can do get for all namespaces. See all of the stuff that is actually running here by default in Kubernetes. So we got all of this stuff actually going, but sometimes the UI might be nice. So, and as Alexander said, it doesn't come out of the box. So sometimes you need to actually try it out yourself or actually, deploy it yourself. So if you want to do it pretty fast, then you can just take this line here. This is like the default one that's set up on GitHub. That it's just gonna take the code in here. This could be in some cases a bit risky, right? Just pointing towards some code on the big dangerous internet. But in this case, I trust them. I put my trust in them.
But Anders, can you explain what the apply does?
Yes. So the apply, pretty much what it does is trying to take whatever is in this YAML file and just say push that towards the Kubernetes cluster. So what we saw right before here is we have a kubectl get nodes. So we ensure this is the cluster we're actually pointing towards. And then if we take a look at this file here, let's just go to it and see how it looks. So we talked about these kinds. So there's a lot of different objects here.
I'm not sorry to interrupt, but can you zoom in a little bit maybe?
I can of course do that.
Great.
Then we
Thanks.
have the namespace. That's the bad part of having a big screen. Everything looks fine. Then we have different kinds here: namespace, service account. Then we have the service. That's one of the few we know. Secret. There's a lot of different things here. So all these kinds that's relevant. So what we do when we run this apply is we're gonna apply all of it, and this is one we know, right? The deployment. So you can see this dashboard. It's running in the exact same way that we run an application later on. So all of these tools is actually using the built-in stuff that it's also exposing to developers. So when we run the apply, we are telling Kubernetes, please take all of these, let's say, objects here and try to apply them into the Kubernetes cluster and host them.
I think one important thing to notice here is that every time Anders has these 3 dashes, if you're not so familiar with YAML, that actually means that it's kind of a new file. So when we apply this, it's not like we can do as much as we want in a file, as long as every time we create a new kind, a new object, we can have 3 dashes and then we can create a new one. So we don't have to create 100 files. If we, for example, we just want to create a namespace, it might be smarter just to put it in the top like they did here.
And that's these lines Alexander's talking about.
Yes.
So let's try to run it and see what happens. So as you can see here, a lot of stuff was created. And then what happens if we run it again? Then it just tells me all of these stuff was unchanged. So nothing changed. I just saw a warning here.
Yeah.
Created by no. We're just gonna ignore that one.
Not important.
Nothing broke. Let's hope that. But normally it'll try to just check up if the state is actually as you expect it to be, or if you have done a change, for instance, change the image tag, then it would redeploy that resource. So as the next step, so we did that one. Then it wants us to run this kubectl proxy. And pretty much what kubectl proxy does is expose some internal stuff that was not meant to be exposed. Isn't that a somewhat precise description, Alexander?
Yeah, I think we can go with that.
So yeah, but pretty much it exposes a lot of our Kubernetes resources, or you can say services. But you can also set it up correctly by using a service and these load balancer tags and everything. But that's not in the official guide. So that's normally for, you can say, people sending it up localhost. If you set it up more correctly, then you would set up a service and maybe a load balancer in front of it. Then we can try to access it, but then we might get an issue because it's telling us to access, and this one is from last time I spun it up. But we do not have a token, so we cannot really sign in. So we need to actually create a user that has access to it. So I've cheated a bit. And I can probably do a raw, right? Yes.
Yeah, you can. I know that. You can do that for a fact.
Yeah, that one we don't wanna. It's clear. Kubectl apply.
You misspelled it.
I cannot spell. And now I created a user. So pretty much, if you take a look at this one, it creates a service account, and then I just tell the Kubernetes that this one should be a cluster admin. So it got a lot of access. So now I should be able to actually use this user to log in. And then there's this find command here. So all of this is actually just directly stolen from their documentation regarding this dashboard. Oh.
And that one is for PowerShell. There is also something for Bash, if you want to use that instead. I think it's in the documentation.
So Anders, can you zoom in on Visual Studio as well?
Yeah, I can. Oh, so this one, the terminal. Yeah.
Yes.
Our terminal.
Yes. So, and we can actually get this token in here. I can also zoom in here. So now we actually get a nice UI.
And one tip here is that Anders can just press update because it's a localhost, so it always keeps the same token forever. So if he presses update, next time he's logged out, he will just be able to log in without doing all this terminal stuff.
So now we're taking a look at all namespaces. So we can actually see a lot of stuff is already running, and we can also see this Kubernetes dashboard that we just installed. You can actually see the Kubernetes dashboard pod in the dashboard. So if I for instance kill this pod, then the dashboard will stop working until Kubernetes spin up a new one. So if we take a look at deployments, there should hopefully be a Kubernetes dashboard deployment. So what this one ensures is that there will always be one pod, or at least it tries to ensure there will always be one pod live. So if I kill the pod, then I don't know, we can just try it, see what happens. And I refresh. Yeah, so I kill stuff. Now we just hope it gets up and running again. Yeah, looks like it. So, oh, unknown error. Yeah, so now it's up and running again, and you can see it just ran for 15 seconds. So that's Kubernetes trying to keep everything in the state that you have actually set it to do. If I instead delete the deployment, yeah, then I'm gone. Then I will not be getting it back. Then I can do the apply again. So now we have the dashboard up and running, and we have Kubernetes up and running. So let's try to create our first actual deployment to Kubernetes. So I think Alexander, he said the documentation is pretty good. So actually, let's try to take a look at the documentation to see if we can actually use that one. So what I did when I searched for documentation is pretty much just search for kubectl deployment or Kubernetes deployment, and then something like YAML or whatever. Then you come into the official documentation. Let's just try to see if we can find it. So the documentation of Kubernetes is pretty good, I would say. So here, and they have a pretty good example of how to creating a deployment. So let's just try to use that one. And we're just going to put in a new file here. That's not a new item. That's fine. Oh.
I don't know. How do you do a YAML file in Visual Studio, Anders?
I thought I just added. It's probably because I right-clicked the wrong place. Can I do like? I can just add it, I guess. Is it here? Did I right-click on the solution?
I have no idea. Do it in Visual Studio Code. That works.
Yeah, we can do. Yeah, I think that's actually better because at least I screwed that up yesterday when I tried stuff. So we just do it in code instead. No one likes Visual Studio anyways, right? So in here we add a new file. Let's add a new file. We call it api.yaml. Where did my api.yaml go? Come on. There goes the api.yaml. So we're going to put it in here. Docker started. Yeah, we don't care about Docker. So we have a few things here regarding Nginx. Ours, we don't really want to be called Nginx, so let's just replace that with API. So let's take a look. So that's the name of the deployment. That's the label. We have replicas 3. That's fine for now. Match label API. Set the label to API. Oh, then we have the image down here, right? That we want to be different. And port 80 is fine. So this is actually similar to what I wrote in here. I did my Docker build command. You see I wrote API and tag 1. So that's the one we want here. So this would actually get the service up and running on Kubernetes. Then we will just take a look here. And I'll just, for good order, I will actually just close this one down so we have the ports open. Let's just take a look here if anything is running. Nope, nothing is running on the port 80. Now we have the deployment. So now we're going to create a new file with these 3 slices. And let's try to see if we can find the service instead.
Yeah, because we want to be able to access the pods we're spinning off in the deployment.
Yes, because an API is not that much fun if you cannot access it. So let's take a look at the service. This should be fine, as long as I remember to change the name. My service, let's call it API again here. And now we have this selector that Alexander talked about. That's pretty important. If you forget to change that one, then it's not going to work. And the target port, yeah.
And it has to match what you have on, is it line 11? I can't remember which one. There's a lot of
this line, I think, because that's the template for the pod. So it's the pod label.
You're probably right.
So yes, so we have set the selector correct here. We set the port here. So this is similar to the -p command we used in the Docker run, where we actually want to expose the port on what port I want to expose on my computer, and then what port I want to expose on But Alexander talked about something called type. So currently it doesn't have a type in here. So let's just see if the documentation tells us anything regarding type. There's the node port Alexander talked about, and then there's the load balancer he talked about. So we want to set the load balancer, and that's because Docker gives us something out of the box that it will just create a load balancer if we use this load balancer tag. So let's try to use that one, and that was in. And that's where I said the YAML can be a pain in the ass, because if I do like this or like this, then stuff breaks and no one is happy then. So let's do it right first time, or at least try. So now we actually have the API YAML, and I can see we are not going to be anywhere close to getting through this all of the stuff.
That's fine.
But there's a pretty nice GitHub page that hopefully should document if you feel like going through a lot of the other tasks later on. So let's see if we can get this up and running. And we have this API, and then go API here, and then we had our API YAML file here. So let's just do a cat. Oh no. So that looks right. Let's try to apply it. At least it tells us that it has actually created the deployment and it's created the service. Let's take a look at our dashboards. Oh, it looks like something new is coming. So that's under pods. So you can actually see it spun up 3 pods. And a good thing is they're all green. So it doesn't seem like they have crashed yet. So I haven't done any mistakes, it seems. And if we go, this is the logs. So similar to how I can see what it prints out if I go to my Visual Studio, then for each of these pods, I can actually see the logs. So let's see if we can actually access it. So if we go to, so again, I can go to localhost, and it's on port 80, it should be exposed, and let's try to see the environment. So now you can see it's changed, right? This seems different. So let's try to take a look if this is actually similar to what we see inside Kubernetes. So what we can see now is I hit this pod. I can actually remember if it's actually some logging. Let's try to see. Nope, there's no logging. So if I had lowered my log level to maybe debug, then I would actually be able to see that this pod has been invoked.
Or just written console.write line.
Yeah. Since we have done this very, very simple one, then browsers have a tendency to cache stuff. So trying to hit one of the other ones can be pretty hard. So you can see it doesn't really try to hit any of the others. So if you instead use curl, then we should be able to see that we can hit different ones. And this might be a bit small, so let's try to zoom in.
It's the same.
It's
hey.
No, it's different. Okay. So you can see it's a bit random which one it's hitting, but it hits different pods. And as we saw before with the dashboard, here we can also just if we feel like going on a killing spree, we can just kill them off.
And we can see that in the top it starts to create a new one. So one of them dies and the other one is created.
Yes. And as I can see, time is running. I don't know if we should just cheat a little bit.
Yeah, either that or just go through what we would have talked about.
We can also do that. Let's do that. So as time is running, and I think also me and Alexander normally would spend a whole day trying to teach our interns about this, then there's a lot of stuff and there's a lot of new information, especially if you've not touched upon this before. Then so let's just try to go through it. So this one is just deploying it. So now you actually got the basics up and running, and you can actually So if you, for instance, check out this point, then you're at the same point that I was at right now. You've created the YAML file for it. Trying to access the different parts, that's what we just did. So the next task, that was actually trying to utilize it. So to utilize this API from another API. So here we wanted to create a new API. This API, the only task was for this API to invoke the other API. So we should invoke one API, and then that one should invoke internally inside Kubernetes the other one. That's normally how these microservices work. You don't necessarily want to expose all of them. Sometimes it just wants to be an internal microservice. That could be one sending notifications and stuff like that. You don't want to expose that one to everyone in the world. So that's what we want to showcase here. And here we also wanted to showcase there's this type that's called load balancer, but there's also the one that's called cluster IP. So if we, instead of load balancer inside here, had called it cluster IP, then we would not be able to access it. But another service inside this Kubernetes cluster would be able to access it. So that's about controlling who can access the services. Do we actually want to expose it externally, or do we just want to expose it to other services internally? Then so just a very simple API would create here, and as part of that, just do like a simple get call to the other service using the internal API DNS. So as you can see up here, we are not writing localhost. Instead, we're writing API-service, because that's the service name we actually see in here. So that's in here. So we can see the external endpoint is here, but there's also an internal endpoint here that we can access.
And that's pretty nice. For example, the external endpoint, it will not change on Anders' computer, but let's say you're in the cloud, the external endpoint at some point might, for example, change the IP. So you will not point to that one, but instead you'll point to something totally different that you don't own. And then your stuff wouldn't work as well as external endpoint. And for example, Google, for each external endpoint you need, it will cost X amount of money. So it's pretty nice if you can kind of have, only one way to access everything in your cluster. And that way you can save some money because the cloud providers earn enough, so we don't have to give them anything. Just try to keep it as low cost as possible.
Yes, and so now we've showcased that one. And then there was a pretty good question previously regarding these databases, and does it even make sense? And sometimes it makes sense to just say, I don't care about my data if I'm going to test something locally. But other times it might be nice that you can actually store some data there, and then when you turn off your computer or anything, you actually still have your data. Or when you just turn off the server, or whenever, if it crashes for any reason, it might not be so nice to lose all of your data in your database. So can you actually just get your data hosted somewhere? And you can do that. So in this one, we're creating a very simple service to store some data in a file. What we then showcase first is if we just push it up there and it dies, then we lose our data. So when we kill it, we don't have any data next time. So instead, we can use something called a persistent volume claim. And that's pretty much just Kubernetes mapping into whatever disk it's hosted on. You can also do them for NFS storage or Ceph storage, and all of these cloud provider storage, S3 storage. So there's a lot of different providers. So in the case of Docker here, there's a storage provider internally in it that we can just utilize, which is just going to store on my local computer. So you can see I reserve 3 gigabytes of data on my local computer for storing this single file. So
Anders,
yeah.
sorry, a quick question.
Yes.
From Abdul. If you make a front end as a container and needed to retrieve data from the back end, which is also a container, do both front end and back end need a service or just a back end?
So you can say both of them need a service, but they don't both need to be a load balancer. Or it depends on how the front end is working. Isn't that correctly, Alexander?
Yeah, if you, for example, have a single page application like Angular, you would need to do, for example, something called an ingress or some kind of gateway where you maybe create a service that the only thing it does is actually forwarding all the other. You would create a microservice that are exposed to the outside world that just forwards all the calls to all the others. Yeah, so you need some kind of external service for the front end that has a URL you could access, and then you could do some stuff inside the cluster where if you access it on /API, you would be forwarded to the API instead of the front end.
Yes, but it can also, depending on what kind of front end it is. If it's the server side front end, then that one could also actually just access the other services. But if it's a client side, then the APIs calls or whatever you do from the front end would actually need to have some way of accessing the APIs in the back end. Yeah, so the last task was pretty much to set up this API storage. And that's also pretty simple in the Docker version. That depends on your cloud providers on how you can do that. And there's a lot of different ways of doing this. You can also set up your own storage inside your cluster using where you just host on different VMs and everything. So that's a whole topic in itself, trying to host stuff on Kubernetes. And then there's a lot of extra stuff if people are bored. But yeah, pretty much there's a lot of stuff. And I think I think the skill level, we haven't really touched upon what the skill level people are. But this is a pretty good task to actually, if you know this, there's a lot of need for this in the industry, I would say. It seems like a lot of companies are moving in this direction using, you can say in this case, it's pure Kubernetes. Out in our world, in most of our departments, we're using something called OpenShift, which is like built on top of Kubernetes. So we can still use all of these Kubernetes commands. And then instead of this UI, we have a enterprise UI. So we actually have some login using connected to our Active Directory and stuff like that we get out of the box by paying a ton of money to Red Hat. And then there exist other. So there's a lot of services built on top of Kubernetes. There's also something called Rancher that can also help you setting up clusters, etc.
And that's free.
That's free.
At least without service, it's free. Yeah. They have a service model, but it's free. Yes. I don't know if we have anything more other than questions. If anybody has anything.
I think we have entered the questions period of time, if we are supposed to keep the time schedule at least. So are there any questions?
If you do have any questions, you're welcome to take the microphone.
Indeed. And also, if you have any feedback, I think we should probably have been a bit better to grasp the level before we started. If people actually knew much about, can we agree that Firefox is the supreme ruler? Never.
Betrayal.
But yeah.
I think I'll go for Opera. The Opera web browser then.
That's the Norwegian one.
Yeah, that's right.
Thank you, Ulrik.
Thank you.
You can continue your discussion on the browser issue offline afterwards, if you like. So if there's no further questions, I think we'll say thank you very much, guys. It was so great to see you again. It's always nice when some of our first community members decide to give back. And I think that's the first time in an Orbit Lab event that someone said killing spree. So yeah, that was new. So I wish you all a great evening, and remember to keep an eye out for more events coming up. We have a few more in the pipeline. So and always, if you have any suggestions, or if any of you have any topic that you would like to speak about at an Orbit Lab event, then please do get in contact. And as I said, I'll send out the material tomorrow with the slides and this video recording as well. So if any of you have any questions on the back burner, then I'll be happy to put you in contact with these two guys. So, and of course, we would give you a massive applause, but you'll have to do with jazz hands, I suppose.
That's perfect.
So thank you, guys.
Yeah. Thank you for having us.
Anytime. Have a good evening, everyone.
Yeah, you too.